Hello everyone. Welcome to Experiment 9. In this experiment, we implement two voice related capabilities in Python. The first is text to speech, abbreviated as TTS. Given a piece of text, the system reads it aloud and generates an audio file. So the second is speech to text, abbreviated STT. So given audio from the microphone or a file, the system listens and converts it into a written text. So together, these two technologies are the foundation of voice assistants like Google Assistant, Siri, and Alexa. So we use two Python libraries, GTTS for text to speech and speech recognition for speech to text. Okay. So while coming to the code, uh, as a first step, we are installing the libraries. So we install three things: GTTS, which is Google Text to Speech Library, and speech recognition for capturing and transcribing the audio. PyAudio, which is needed to access the microphone hardware. In Colab, we also run apt get install Port Audio 19 day first. So Port Audio is a system level audio library that PyAudio depends on. So without it, PyAudio can't access any audio device. Okay. So while moving to the second step, we are importing the libraries. Okay, so we import GTTS from the GTTS modules. We import speech recognition as SR, the standard alias used in all speech recognition documentation. So we import IPython's audio and display functions. So these allow us to play audio directly inside the Collab notebook cell without needing an external media player. Okay, so now we are moving on to the step 3 and step 4. Okay, so first the step 3. Here, um, step 3 and 4 cover the text to speech functionality. So we define a function called text to speech that takes the input text, language code, output file name, and slow flag as parameters. So inside the function, we first check the text is not empty. So we then we create a GTTS object. We pass the text and the language code like EN for English and whether to speak slowly. So we call tts.save to write the audio to an MP3 file. Then we call display function. Displays audio directly inside the Collab notebook. So in step 4, what we are doing is we test this with the three examples. First, a basic English sentence. Second, I tested a technical sentence about AI. The third is I use input. So I can type any custom sentence and hear it spoken aloud. So notice that GTTS supports over 30 languages. So if you change the language to TA, it will speak in Tamil. If we change it to language equal to HI for Hindi, and we can also change language equal to FR for French and so on. Okay. So now we are moving on to the step 5 and 6. Okay. So here in step 5, um, it defines the microphone based STT function called speech to text mic. So we create a recognizer object from the speech recognition library. So we then open a microphone using sr.microphone function as a context manager. So we call adjust for ambient noise for half a second. So this calibrates the microphone to filter out the background noise. So then we call the recognizer.listen function. This records audio until the user stops speaking. So with a timeout of 5 seconds. Okay. So then once we have the audio, we call recognize underscore Google. So this sends the audio data to the Google Speech API, so which transcribes it and returns to the text. So we handle three exceptions: wait timeout error if no speech was detected, then an unknown value error if the audio was unclear, and request error if the Google's API is unreachable. So while coming to the step 6, here we are defining speech to text from the file. So this works on the saved audio file instead of microphone. So this is useful in Collab because Collab often cannot access the microphone directly. So here we also handle MP3 to wave conversion using PyDub because speech recognition only works on wave format. After that, we are moving on to the step 7. So here, what we are doing is um, step 7 is most interesting part, the full round trip demonstration. So we start with a text string, Python is powerful programming language used in artificial intelligence and data science. So here first we pass this to the GTTS and save it as an MP3 file. So the audio widget lets us hear it. Then we pass the same MP3 to our speech to text from the file function. So it converts it into the wave, and then it sends to the Google Speech API and returns the transcription. So finally we compare the original text with the transcribed text side by side. So in most of the cases, you will see the transcription matches the original very closely. So maybe with the minor differences in capitalizations or punctuation. So this is completely normal for speech recognition system. So perfect word for word matching is difficult even for humans in a noisy environment. So this round trip demo proves that our TTS output is clear and enough for STT system to understand. Okay. So while moving on to the step 8, which is menu driven application. So we wrap everything into a menu driven application. The function run STT TTS app displays a menu with four options: text to speech. The user types any text, optionally chooses a language, and hears it spoken. The option 2 is audio file to the text. The user provides a file path and system transcribes it. The option 3 is microphone to text. The user speaks into the microphone and sees the transcription. The option 4 is exit. The while loop, the while true loop keeps the menu running until the user selects the exit. So each option calls the corresponding function we built in the earlier steps. So invalid input shows the helpful error message. Okay. So this is our output, and the result is, so we successfully implemented a speech to text and text to speech system in Python. So for TTS we use GTTS, which connects the Google text to speech servers and returns a natural sounding audio. So for STT we use speech recognition, which can work with both microphone input and audio files. So we also demonstrated a full round trip converting text to audio and back to text. Okay. So then proving both these systems work correctly and together. So this is the foundation for building complete voice assistance, accessibility tools, and automated transcription system. So that's all for today. Thank you.